You've been waiting for motivation to show up like it's a guest who's running late. You tell yourself, once I feel ready, I'll start. Once I'm energized, I'll push. Once I'm inspired, I'll create. But here's the uncomfortable truth that neuroscience has been sitting on for decades. Motivation doesn't come before action. The biology is actually reversed. And until you understand the molecule at the center of that reversal, you'll keep waiting at a door that opens from the other side. That molecule is dopamine, and I'd bet that almost everything you've heard about it is incomplete or outright wrong. Most people think dopamine is the pleasure chemical, the reward signal, the thing that floods your brain when you eat sugar or scroll social media or win something. And while that's partially true, it misses the more powerful and far more actionable truth. Dopamine isn't primarily about pleasure, it's about the anticipation of reward. It's the engine of wanting, not having. And that distinction between wanting and having is the key to understanding why some people seem wired for relentless drive, while others feel perpetually stuck. It's also the key to changing which one you are. In the next several minutes, we're going to move through the actual biology of how dopamine is synthesized, how it drives you toward goals, how modern life has quietly hijacked that system, and, critically, 3 specific, research-supported tools you can apply starting today to recalibrate your dopamine circuitry and rebuild sustainable motivation. This isn't about hacks. This is about understanding the machinery well enough to work with it instead of against it. Let's start at the molecular level, because the mechanism matters here. Dopamine is a catecholamine neurotransmitter, which means it's a chemical messenger derived from the amino acid tyrosine, which you get through dietary protein. Inside your neurons, specifically in a region called the ventral tegmental area, deep in the midbrain, dopamine is synthesized and then released into circuits that project throughout the brain. The 2 most relevant pathways for what we're discussing are the mesolimbic pathway, which runs from the VTA into the nucleus accumbens and limbic system, and the mesocortical pathway, which connects to the prefrontal cortex, the seat of planning, decision-making, and self-regulation. When these circuits are functioning well, you feel motivated, focused, and capable of delaying gratification. When they're dysregulated, you feel flat, distracted, and impulsive. The entire range of human ambition lives inside those 2 pathways. Here's where it gets genuinely fascinating. A landmark set of experiments conducted by Dr. Wolfram Schultz at Cambridge, work that eventually contributed to a Nobel Prize in physiology, revealed something that reshaped our entire understanding of reward. Schultz trained monkeys to expect a reward, a drop of juice, after a specific cue. Initially, dopamine neurons fired when the juice arrived, at the reward itself. But over time, something shifted. The dopamine neurons stopped firing at the juice. They started firing at the cue that predicted the juice. The anticipation became the dopamine event, not the reward. And when the predicted reward was withheld, dopamine activity dropped below baseline, creating what researchers call a negative prediction error, a kind of neurological disappointment. What this tells us is that your brain's dopamine system is fundamentally a prediction and anticipation machine. It's oriented toward the future, not the present. Which is why achieving a goal often feels strangely hollow. The dopamine was in the chase, not the catch. Understanding this changes how you should think about building motivation. The goal isn't to make the outcome feel better. The goal is to make the pursuit feel more rewarding, and you can actually do that deliberately. This brings us to the first tool, what some researchers informally call a dopamine reset, and what you can think of as strategic baseline recovery. Here's the problem most high achievers run into. They're constantly seeking stimulation. Coffee, social media, back-to-back achievement, constant novelty. Each of those activities releases dopamine, but the brain is not a static system. It's adaptive. Every time you flood dopamine circuits with a large, easy stimulus, your receptors downregulate. They become less sensitive. The baseline drops. And now you need more stimulation to feel the same level of drive. This is the neurological basis of what people colloquially call burnout. It's not a character flaw. It's receptor desensitization. The reset protocol works by deliberately removing high dopamine activities for a defined period, typically 24 to 48 hours. During this window, you avoid social media, processed foods, recreational substances, excessive entertainment, and any other easy reward behaviors. What you're left with is low stimulation existence, walking, reading, conversation, cooking, light movement. It feels uncomfortable at first, often intensely so. That discomfort is the signal that your system is recalibrating. By the end of the reset window, mundane activities start to feel genuinely pleasurable again. Your sensitivity has partially restored. Research from Dr. Anna Lemke at Stanford, whose work on dopamine and compulsive behavior has been extensively published, suggests that these low stimulation windows are among the most effective strategies for restoring what she calls the dopamine homeostasis, the equilibrium between reward seeking and reward satisfaction. You don't need to do this every week. Once a month, or when you notice persistent motivational flatness, is often sufficient. The key variable is actually completing it, not planning it. Now let's talk about habit architecture, because this is where the prediction error mechanism becomes a genuine tool rather than just an interesting fact. When you're trying to build a new behavior, exercise, deep work, writing, whatever it is, the early phase is always the hardest. Your dopamine system hasn't yet attached a reward prediction to the cue. There's no anticipatory spike. The action just feels like effort without payoff. Most people interpret this as evidence that they don't have the discipline for the habit. They're wrong. They simply haven't repeated the cue behavior pairing enough times for the dopamine prediction to anchor. The research on this, particularly from Dr. Anne Graybiel's work at MIT on habit formation in the basal ganglia, suggests that habits are encoded not as behaviors, but as chunked sequences with embedded reward signals. The brain isn't learning, do this action. It's learning, this cue predicts this reward. Pursue it. Which means your job, especially in the first 2 to 4 weeks of any new habit, is to artificially amplify the reward signal at the point of completion. Celebrate the behavior immediately and genuinely, not perfunctorily. Tell your nervous system that this action was worth doing. Over time, that signal becomes automatic. The anticipation builds, and suddenly, the behavior starts pulling you toward it rather than requiring a push. The second protocol builds directly on this, what I'd call subjective effort reframing, and there's now a compelling body of research behind it. Dr. Aaliyah Crum at Stanford has spent years studying how mindset shapes physiological response, and her findings on effort are particularly relevant here. When people reframe the discomfort of challenging work not as something to tolerate, but as the actual source of the reward, when they internally narrate, "This difficulty is the point," dopamine release patterns shift. The struggle itself becomes the cue that predicts growth, and growth is deeply rewarding to the nervous system. This isn't positive thinking in the shallow sense. It's a cognitive reframe that changes the prediction your dopamine system is making. Instead of effort leads to completion, which leads to reward, the circuit becomes effort is the reward signal. Practically, this means when you sit down for a hard work session and feel resistance, you deliberately reframe that resistance as a meaningful signal rather than obstacle. Say it internally if you need to. This is the work. This is what growth feels like. Research suggests this simple practice can measurably increase persistence, mood, and performance on cognitively demanding tasks. Try it for 2 weeks and see what shifts. Before we get to the third tool, let's name the most common mistake people make with dopamine, and it's one that the modern attention economy is specifically designed to exploit. Dopamine stacking is the habit of layering multiple high-stimulation inputs simultaneously. Listening to a podcast while eating, while scrolling, while half-watching a show. Each of those activities provides a mild dopamine hit. Combined, they generate a level of stimulation your ancestors' nervous systems never evolved to handle. The result is not increased satisfaction. It's accelerated receptor desensitization. You end up needing more inputs to feel anything at all. Worse, when you try to do single-focus work, writing, reading, thinking, it feels unbearably boring by comparison. You haven't lost your ability to focus. You've raised your stimulation threshold above what single-task work can provide. The fix is deliberate monotasking during your highest-value work periods. One input, one task, protected time. This isn't asceticism, it's receptor preservation. The third protocol is what I'd call a morning dopamine foundation, and it targets the first 60 to 90 minutes of your day. The neurological window that sets your arousal and reward baseline for the subsequent 12 to 14 hours. Here's the stack, and the specifics matter. Within the first 30 minutes of waking, get outside or near a bright window for 10 to 20 minutes of natural light exposure. This entrains your circadian rhythm and supports the cortisol awakening response, which is your body's natural dopamine priming mechanism. Next, delay caffeine for 90 to 120 minutes after waking. Caffeine works partly by increasing dopamine receptor sensitivity, but if you take it during the cortisol peak, you blunt both the cortisol response and reduce caffeine's effectiveness later. Wait, then have your coffee. Third, if you're able, begin your highest priority cognitive task within that first 90-minute window. Before email, before social media, before any input that passively entertains you. Your dopamine system is freshest, your prefrontal cortex is most receptive, and the reward prediction from completing meaningful work will carry forward through the day. These 3 actions, light, delayed caffeine, early deep work, aren't complicated, but together they create a neurological environment where sustained motivation is far more accessible. The through line across everything we've covered is this: dopamine is not a mood, it's a system, and like any biological system, it responds to inputs, patterns, and consistency over time. You can dysregulate it through constant overstimulation, reward stacking, and passive consumption. Or you can calibrate it through deliberate resets, reward anchoring, effort reframing, and protecting the windows when your brain is primed to engage. The motivation you've been waiting for isn't going to arrive on its own, but now you understand what actually generates it. And more importantly, you have specific tools to start building it today. The biology was never working against you. You just didn't have the map yet.